What
one of
happened?
one of the guys, one of the supervisors on another sort went in for surgery last week, and then one of one of the other supervisors um, is becoming a preacher, and so he made the recommendation. And one of the other ladies, she was like, "That's why we have a preacher on our sort. That's why we need a preacher." It was a good prayer.
Good.
But yeah, it's cool. I I think it helps a
Hmm.
lot.
That was cool.
Yeah, it was a first. It's a benefit of living in the Bible Belt.
Yes.
You can do that kind of thing, and most people will be okay with it.
Yeah. And not too many will make loud noises like, what is wrong with you for even thinking that?
Yeah. Actually, we all held hands too in a
Oh.
circle. Yeah, it's kind of a Baptist thing, I guess. Yeah, it was cool. Honestly, I have one coworker who I don't think particularly likes me, but held his hand today. He was next to me in the prayer circle.
It's time to let go of those bad feelings.
Yeah, I guess so. Uh, so, what did y'all think of this lesson?
Uh,
In some ways, I'm getting it pretty well, and in other ways, I'm having a hard time not mixing things up. And I'm the which one is the parameter, which is p, and which number is my parameter, which is p, and which number is my point statistic, which is p hat. At least in some of the homework, I was like, I'm not sure if I'm getting this backwards or not. The confidence level kind of makes sense, though.
Hmm.
Just plug the numbers in and follow the math.
Yeah, I couldn't figure out how to get the Excel spreadsheet to work right. Like no matter what I did, I still had a confidence interval of 0.00 and 0.00.
hmm.
So if y'all could figure that out.
We will see. Oops. Okay.
Oh, Edward, how's your new job going?
That's really good. Thanks. It's a new job, so it's not really much to say. It seems pretty fun.
What are you doing?
Oh, I just try to sell people printers and laptops. I'm just a tech at Staples.
Picking the right one is a big deal.
Mm-hmm.
Well, here you go, Laura. Question 3 is just for you.
Oh, I haven't even opened it yet. Are we starting the quiz?
That's what I thought.
Okay.
I see a symbol in question 3 that I haven't seen yet.
Yes.
Pie not hat.
Another kind of,
Pie squiggly hat.
yeah. Kind of looks like a toupee, actually.
Hmm.
Toupee pea. Actually, it would be P toupee.
A really bad one too. So yeah, the symbol for the true population proportion is p hat. Yes. No, it's figuring out which number sometimes when he's trying to get us to think about it, he just throws numbers out and you're supposed to just know which one is p, which is the parameter, and which one is p hat, which is the statistic. And I'm like, not positive.
Okay, I thought the true population proportion was P.
Yes. Yes, the true population proportion is P because that is the parameter. Excuse me.
Yeah,
P hat is the statistic.
I just remember the simple one, just normal P is the one that is unrealistic, so we don't use it very often. I can take question 4.
Okay.
It says, for the next two questions, suppose n equals 100 and p equals 0.25 and p hat equals 0.1. The requirements for constructing a confidence interval are satisfied. I don't know.
We have to do that it's normally distributed thing. N times P is greater than or equal to 10.
Well, P.
So 100 times 0.25,
Would be 25.
yeah, is greater than 10 or equal to 10. And then the N times 1 minus P, you have to do both.
Could be even higher because it would be 75.
So then we're good.
Cool.
All right. The next one, question 5. The requirements for conducting
Conduct.
Con-
They mean
conducting a hypothesis test are satisfied. Are we sure we didn't get one of them mixed up? Because I only really remember one, the one we just did, but
Yeah, I don't remember the requirement for the hypothesis test.
because I'm going to assume we forgot. I think this one is true because I think the hypothesis test, the requirements for the hypothesis test is the what,
Same as,
n times p, was it?
I know the rule that says that the shape is normal if that n times p is greater than or equal to 10 and the n times 1 minus p is greater than or equal to 10. I know that's a rule. I don't remember which one is which, but I guess. So maybe that's not the requirements for constructing a confidence interval. Maybe that's the requirements for the hypothesis test. Is that what you're saying?
Maybe they might both be the same.
They might be.
well, I'm looking in the textbook and it says the confidence intervals are valid whenever n times p hat is greater than or equal to 10 and n times 1 minus p hat. So I think one of them is using p hat and one of them is using p.
You guys
But
hear
it looks
me?
like they're the same equation.
Hi,
Oh,
Nick.
yeah, I can hear you now. Yeah,
Okay,
I think that's more along the lines because when I was reading this, is like these sound similar, but
I was gonna say something for the previous question. We were supposed to use p hat instead of p.
yeah,
Oh, okay.
yeah, we just got that because I was like,
Okay.
I think we mixed this up whenever we got the 5.
So for 4, it was the n times p hat.
Yeah.
And then 5, it was the n times p.
Let's see.
So it would n times p hat be. Perfect timing, Anetic.
N. Minus.
I think it would still work.
It still works, yeah.
Because
What was the other one?
a tenth of 100 is 10.
What was, because the first one will work, but the other one was n times p, or was it n? I forgot the
There's-
1
there's-
minus whatever.
Yeah, the n times 1 minus p or n times 1 minus p hat. They're exactly the same. They just changed the p's to p hats.
Okay, yeah,
And so-
they'll both be fine.
One gives you 10, one gives you 90. Okay. True. And p hat is for confidence interval.
Genetic.
Yes.
So p hat is for the confidence interval, and then p is for the hypothesis test.
Let me see.
I only had the one rule written down. I must have missed the second one. When it's the n times p greater than or equal to 10 and the n times 1 minus p greater than or equal to 10, it proves the shape is normal. So that has to go with the hypothesis test, that we've got normal distribution. So I
From
think,
the sample.
Yes.
Can you guys see my screen?
oh, hold on.
It's right there. Confidence interval. We're supposed to use p hat.
Okay. So the p hat one just goes to the confidence interval. I'll have to. Thanks, Anetic.
Okay.
Yep.
Cool.
I'm gonna have to watch that one again. Anetic, do you want to take 6?
Sure. A study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. Find p cap the point estimate of the proportion of first-degree murders defendants who are found guilty in this state.
So p hat equals x over n. So that's 45 over 60.
60. I have 0.75.
Me too. Does it save 3 decimal places?
Yeah, there is. I just rounded. If there's no, yeah, 3 is fine. I usually just put 7.5 only.
All right, create a 95% confidence interval for the true proportion of first-degree murder trials in this state, where, I think they meant, the verdict is guilty. Input your answers for the margin of error, lower bound, and upper bound. Okay, so margin of error equals z-score times square root of p times 1 minus p all over n. But before we start that, we're going to find the z-score. Okay. P hat is 0.75. What else have they given us? So P is 45 then?
Hold up. Input 95 seconds. No. Oh wait.
So I think P is
No,
45
no.
and N is 60.
I thought X would be 45 because. Wait. No, wait. Grand sample 45. Yeah. 45 would be X, I think.
Or p hat.
P hat was 0.75.
Yeah, P hat is 45 over 60.
Okay.
And 60 is N. We have a 95, but if we don't know what, but so
So the
45 of the defendants were found guilty, though. Wouldn't that make that P? Those are the number out of 60 that are guilty.
Hold up. I think I'm getting close. I think I typed that in wrong. From the top. Okay. How do we find this? 7.5.
minus 45.
That can't be right. Well, is this the time? Is this one of those times where P hat and P are the same?
Hold on. So it's P. I would for now I would think so. Let's try that for now.
So Z equals 0.75 minus 0.75 all over the square root of 0.75 times 1 minus 0.75 over N is 60. Does that sound right?
Sure. Let's just see what the number turns out to be.
I would think P needs to be something different because that just makes it 0.
Well, we already know Z for the confidence interval. That'll be 1.96 because it's a 95% confidence interval.
Yes. Times the, but we don't know what P, well, okay, so
Do we all agree to use this formula? It's in my screen. Which is 1.96. Each is the Z-score for 95% confidence interval.
oh, but we're doing the margin of error first.
Oh, okay, so this is for the margin of error.
Yes. But it's still 1.96 times, but instead of P hat, it's P. So it's Z times the square root of P times 1 minus P over N for the margin of error. Okay, so I get we're still assuming that P is 0.75.
Yeah.
All right.
Well, the margin of error formula calls for P, not P hat.
Yes. Yes.
So that would just be, I think,
So
45.
How did we find the z-score?
Well, because it's 95%, it's the 1.96.
Okay. 1 point. All right, 1. Like that. That's what I thought.
But the question is,
Times.
what is P?
this is the formula I found in the homework, in the preparation study, to find the
That's the
margin.
that's the confidence interval.
No, this is the margin of error. The confidence interval, you just add or subtract the margin of error from P hat.
Okay, so it is P hat. Because I had written down P.
Okay, in the book it says the margin of error is z times the square root of p times 1 minus p over n. In the very beginning of 3 in this week's chapter.
Yeah, I see it again now too. It is P.
This is hard. Right.
So it's
Oops.
1.9. But really the only question we need to find out is what is P.
What's p?
That would be the true proportion from the true population proportion.
No, yes. P is the parameter. P hat is the statistic.
Yeah.
Now, I was just going to assume it was 45 before. Well, let's see what I get. 1.96 times the square root of 45 times 1 minus 45 all over 60. All right, Excel, what do we get?
I'm getting a number error the way I put it together.
Negative 1980 divided by 16. Yeah, because it gives you a negative number. You can't, I don't know that you can square root a negative number. I think that gets into imaginary numbers. So 45 is obviously not this. So maybe it just needs to be 0.7. This is that time where the parameter and the statistic are assumed to be the same.
equals P. Portion of positive results equals P. Maybe, hold up. Okay, P hat is definitely, okay, we got P hat right.
Correct.
So we don't know what P hat is. No, not P hat. We don't know what P is. So we have to use P hat.
Well, I'm looking at the one of the examples from the chapter, and it so look at step 4 in the last example from the chapter.
You mean in the book, or you mean on the preparation assignment?
In the book.
So the last, so
I'm
Not
onto something.
actually. It's
Yeah, keep going.
so 4 point what? 5.
yeah, it's 4.1. Step 4. It gives an example of P.
Step 4.
Oh,
The assumed value.
You have 0.7.
So P is the assumed value.
I don't see him giving us an assumed value somewhere between 6 and 7.
six.
Okay. A study of first-degree murder trials was conducted in another state. A random sample of 60 people in the trial for first-degree murder was taken. 45 of the defendants were found guilty. So we divided 45 over 60 gave us P hat, 0.750. At a 95% confidence interval, that makes the 1.96. For the true proportion of first-degree murder trials in this state, where the verdict is guilty.
Oh, oops.
Ooh, I think I just found it.
Okay?
Look, it says in section 3 in the introduction, it says, if no prior estimate for P is available, we can use the following formula to compute our sample size.
Yeah,
Like,
I knew.
compute sample size.
I remember that. I was looking for that because it's like we assume P, we use P hat, but we don't just use P hat. We do something else to it. I couldn't remember what.
Okay. Oh, I see. So we do
not
know the value of P. Sometimes we have prior estimate of the true proportions of successes denoted P. If we have a prior estimate, great. If no prior estimate for P is available, we can use the following formula. N equals Z over 2M squared.
M?
And what is M?
margin of error.
But that's just it. We're trying to find out the margin of error, and
Yeah.
we have to know P, as far as I can see, to find out the margin of error.
Hmm.
And Edic's got something looking
You
at.
guys should look at this slides. And this is the formula that I used to make sure that I got the answer right in the preparation to find the marginal error.
It is.
So
So you use p hat and it came out correct.
yes,
Well, I guess if we don't know what p is, then p hat has to do because we don't have anything to go off of.
But you did plus instead of minus?
no. To find the marginal error, I had to use the z-score, which is 1.96 times. This would be 0.75.
Yes.
So we're gonna use 0.75 for p cap, and then square root of that.
Okay, so when I plugged p hat in, I came up with 0.1095. What did you get, Anetic?
Give me a second. The first time I did, I got 0.047, but the second time I tried, I got a different number. So
So when I do it, I get 1.109567.
That's what I got.
Okay. Meaning that there would be an 11% chance of
Okay, so the margin of error is, I'm gonna round it to 3 places. $0.110. Okay, so now we're figuring out the lower and the upper bounds of the confidence interval. Where'd that go?
and the equation for that is
Back to my,
lower bound p hat.
yeah, p hat plus or minus z times the margin of error that we just figured out.
And look, well, in that formula, I just saw that formula again, and I had p hat in that formula. So maybe that was just a typo. Maybe them showing p in the formula was a typo.
I think we need to say something to somebody because that's what they had in the book. That shouldn't be.
No, it wouldn't be the first typo. We've already seen 3 in this chat, or 2 in the test.
Yeah. All right, so 0.75 minus 1.96 times our margin of error, 0.10956, gives us the lower bound. I've got, for the lower bound, I've got 0.53524. So round it to 3 decimal places, 0.535. Does that sound right to anybody else?
I'm putting it in, writing my equation right now.
Oh, here we go. By 60. One.
I got 0.64, and I
Yeah.
did
Yeah.
P cap minus margin of error.
Okay.
All
right.
It's p hat minus z, the 1.96 times the margin of error. As I thought was the formula.
Yeah, I put that formula and I got 0.535 as well.
Okay. That was from our preparation assignment. P hat plus or minus z times the margin of error.
One.
So that makes the lower bound 0.535.
But it doesn't make sense to me because I
Yeah.
think P hat has to be in the middle of the.
Yeah. So would, like in Eric saying, wouldn't it just be 0.75 minus 0.11?
Look on the page there. P hat plus or minus z times the margin of error. So it's 0.75 minus 1.96 times the 0.1. I unrounded it, so it was I have 0.109 blah 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 instead of 0.110. But it's still
So
like what's right there in your thing, Enetic, the confidence level. P
yeah,
hat plus or minus z, so that's 1.96 times, then what's left there at the end is the margin of error.
yeah, that's right.
So that makes the lower bound 0.535. And I got an upper bound of 0.965.
I got the same.
Mm-hmm. Equals. Hold up. 96. We got that. 0.11.
Does that make sense, Enetic?
Yeah, it makes sense, but I still think that like we should get the same result, like the way you're doing it and the way I'm doing it, but for some reason we're not.
Hold on.
If you look at my in the screen, I'm looking at the preparation thing. So
Preparation assignment, yeah.
where letter D is, it says P cap plus or minus margin of error, and that's what I did, and I got the right answer.
0.75.
But you guys can try
minus
the result you got, and I can try mine, and at the end we'll find out who's right.
Okay, but
Um,
up in number 2. So in the same one, up in number 2 in part 1, it's got p hat plus or minus z, which would be that 1.96 times.
Where is this?
He was on the preparation assignment. So in number 2,
Oh, preparation assignment.
I was taking the formula from number 2. But in number 8, he was the 8D. It just says p hat plus or minus the margin of error.
So I'm gonna try to do it this way, number 2, and see what I get.
Okay, because I'm still with Enetic on this one. Because right. Well, let's see. Number 2.
Actually, wait a minute. Okay, so for the margin of error, we already did z times. So you're right. I was just doing z twice.
Yeah, what were we doing this for? Because I did it the way Enetic was saying. Also, with the p hat plus or minus z, then times the what was that? Missed it.
No, you're
forgetting
right.
what this-
We don't have to. We've already, as of the margin of error, we've already multiplied times the z. So why? All right, never mind. Doesn't matter. We already did it in the margin of error. That changes the lower bound to
640.
yeah 0.640 and the upper bound to 0.860. Is that what you got, Enetic?
Yeah, I haven't done the upper bound,
Okay.
but that's what I got for the first one.
All right, plus. All right, then yeah. Then the upper bound would just be 0.86 rounded up.
Yes.
Yep.
And if you increase the sample size from 60 to 80, that will
What will happen to the width of your confidence interval?
decrease.
It will narrow it, decreasing.
Yeah, it should get lower.
So it should get small. The width should get smaller because the sample size is larger.
hmm
Decrease.
All right, now we get to use the sample size formula. And they actually give us P for this one.
All right, to connect one portion to a portion of one the smallest. Wait. Sample size? Oh, okay, never mind. Wouldn't this just be double? No, wait, no, that half. No, I get Miles to do it from the beginning.
So it's n times p has to be greater than 10, or greater than or equal to 10.
I think that's a different formula. I have a weird formula for the,
The smallest n.
yeah. It's z over m squared.
Well, That we might be able to do that with a different problem, but we only have one number provided for us. Well,
It says where in the book it says where Z is determined by your confidence level, M is your desired margin of error, P is an estimate of the true proportion of successes. If no prior estimate for P is available, we use the following formula to compute the sample size. But I don't think we have all of those numbers. So I was going back to that rule. We only have
Oh, yeah. I think. All right. I understand what you're saying.
we only have P. So
Oh, okay. Yeah. So we did what we do what we did last time with like 0.25.
n divided by 0.5.
Yeah. The smallest it can be is 20.
20.
But then we have to check the other one. 10 divided by 1 minus
oh,
0.5
it's
is
the
the other
same.
half. It's 5. So 20 is the bigger number, 20 is the answer. Okay, 12. Okay, so the answer is 20?
Yeah, that's what I think.
Okay.
So question 12, to conduct a hypothesis test for one proportion, two requirements must be met. Suppose P equals 1/10.
Oh.
What is the smallest n that can be, and both requirements still be met? So that's that n times P greater than or equal to 10, and then n times 1 minus P again, only this time for 1/10.
10. 1 minus 1. Okay. 12.
I think it would be 100.
100.
Yeah, that's what I got because I did it the other way first, and you have to have the
Larger number.
Mhm.
Okay, who's next?
I'll do
I
it.
think it's my turn.
Ah,
Do that or
okay.
not.
Alright, well, I'll just do it. For the water quality study in the reading, about 60% of macroinvertebrates water quality indicators have historically been associated with good health. The researchers suspect the water quality in the area has decreased. They conduct a hypothesis test using a significance level of 0.05 with the following hypothesis. The null is P equals 0.6, and the alternative is P is less than 0.6. So they collect new data. So N is 80 and X is 38. So what are the conditions for conducting a hypothesis test satisfied? 0.6 times 38. No, wait, no, not 38. It would be 80.
So yeah, 80 times 0.6 equals what? It's
Right.
48.
48 true.
80 times 1 minus 0.6.
That's 32.
32. So they're both greater than 10. Yes, true.
Divided by.
And what is P hat? That would
Wouldn't-
be
P hat equals X over N.
Yep.
38
What?
divided by
80.
8.
I got 0.475.
Same as me, 0.475. Okay, so find the test statistic.
or Z.
P hat is our test statistic, I thought, because P is our parameter. So isn't it just the same, 0.475?
Hmm.
I think it might
Maybe.
be the Z score.
Because this needs the test statistic is the let me see.
Or is it the Z score?
The Z score has to do with the test. The P hat has to do with the population.
No, P is the population parameter. P hat is the test statistic, is the statistic.
Mhm.
Or it is a statistic. I'm not positive it's the test statistic.
Well, if it's Z, it would be 1.60, 1.960.
It's too easy.
Maybe not. They say alpha equals 0.05, but they don't state that. They don't state directly that the confidence level is 0.95.
Well, P is like mu when we were looking at quantitative data, and P hat is like X bar.
All right.
Do we want to just figure out the p-value and come back to this?
What we could also, I can put down 1.960, and then if y'all put in 0.475, we'll see which one they consider the test statistic.
Okay. All right, so what is the p-value for this test? I'm a little bit fried. I should know what I'm supposed to do for that.
P-value.
Yeah.
Where do we find p-value?
What question are you guys working on?
Question 16, what is the p-value for this test? And I'm blanking on what we're supposed to do.
I think we can get the answer by plugging these numbers in the Excel sheet.
It definitely does. It has a spot for p-value
In which Excel sheet?
Is
in
the,
the one sample z-test for proportion.
the categorical data, and then you choose the first one.
P-value.
And
I thought I downloaded that and I didn't. All right. So one proportion, is that what you're,
Yeah, one proportion. One
Alright.
proportion z-test, or one sample z-test for proportion.
okay, so get back to, so what are,
8.
okay, so X is 38.
And it is 80,
And is 80.
and it's a
Confidence
9.
level is 95. Null hypothesis equals 0.6. And what kind of test are we doing? Type. Excuse me.
Things
Less than.
less than, yeah.
I see a p-value of a 0.011.
Me too.
And we got p hat right. So it also shows the
0.475.
Yep. And we can try to we can find out if we got the marginal of error right by
Using the confidence interval.
by using this p hat here. Maybe not.
Before we used to be able to find the difference in the confidence intervals and then divide it in half. And that was the margin of error. Okay, so what is the decision of this test?
It's smaller than alpha, so I say we reject the null.
I agree.
Yeah. But wait, what did we get for the 16?
0.011. When you input everything into the new Excel sheet.
Test statistics is 0, right?
I'm sorry, the test statistic.
Z.
That's what I'm putting. But we're gonna see if it's z or p hat.
Maybe it's just Z. Okay, 18. Which of the following best summarizes the conclusion of this test?
I would say D.
There is sufficient evidence to conclude the water quality in the area has decreased.
the null is that the proportion equals 0.6.
And we've rejected the null.
All right, y'all ready to submit?
Where is it? I think I am.
Okay, so what did we think the z-score was
The confidence
for 15?
level is, well, alpha equals 0.05, so that means that the confidence level is 0.95, and the z-score attached to that is 1.960.
Okay. But on our sample z-test for proportions, they have a z-score of negative 2.282. Interesting.
I got that one wrong.
Which one you got wrong?
I got 15 wrong. So that's not the test statistic.
So p hat is the test statistic, possibly.
Yeah.
All right, I'm gonna hit submit the quiz and find out. And 0.475 is wrong too for the test statistic. Maybe you needed to use the z-score they have on this Excel sheet. Looks like we got everything else right.
0.282.
Yeah.
Yeah, I say we use that.
Oh.
Hey, bud. I'm doing a test. You need to get out right now.
Good job, Anetic, on catching that double usage of the z-score.
Yeah, helping us figure out the confidence level versus the
Margin of error.
margin. Yeah.
No problem.
All right.
Gotta get my iPod.
It's fine. Thank you, John. All right, I'm going to go back in and see if 15 is negative 2.282.
Yeah, me too. All right, that's the right that Z score is the test statistic.
Okay.
Nice.
That's a winner.
So I got 14 wrong, and I think I entered the wrong number.
Mhm.
So what's the right answer for 14?
0.475.
0.75.
0.475.
Okay. Okay, I was missing the 5.
Okay. I'm gonna have to go, guys. It's my mom's birthday and everybody's getting here, so it's about to get loud.
Okay.
All right,
So
then.
when are we meeting for the
For next
assignment?
Oh yeah, for the other assignment.
Thank you.
It's technically due Saturday, but
Should we meet
I'd say we
Friday
take care of it tomorrow.
or tomorrow?
Does Thursday or Friday work better for y'all?
Um, can we meet earlier tomorrow?
I
Everything,
think so.
all the days are the same for me, but I have to meet before 3.
Tomorrow.
Yeah. Well, any day. After.
Yeah, I can do that. I get off work around lunchtime, so I'm good after that.
So like,
So wait, that'll be 3. So that'll be before
What?
1 o'clock Mountain Time.
I think my shoes are in here.
That would be like 10 o'clock Mountain Time, so I'm
Yeah.
good. Pretty much
that's
any day.
fine. I can. So that's 11. That's no, backwards. I'm in Pacific now. So 10 o'clock Mountain. That's 9 o'clock my time. Sure.
So how about we shoot for an hour after that though? Because I never know. The past 2 weeks has been worse than Christmas at work for me, so that's saying something.
All right.
More
So
packages than I know what to do with.
what?
If we did what if we did like 11 o'clock Mountain Time? 11
That should be
a.m.
fun.
Yeah, that works for me.
11 o'clock
Okay.
Mountain Time.
Yes.
Alrighty.
All right. See you tomorrow.
Okay, thank you guys.
See you tomorrow, guys. Thanks.
Bye.